Given the following rows from Pascal's triangle, write the circled number as a combination. First, determine the zero-based row number n and the zero-based position k. There are 9 terms, so we have the 9th visual row of Pascal's triangle. The value of n, which is zero-based, is 8. The first position is circled. The value of k, which is zero-based, is 0. The answer is 8. Choose 0. Now we'll move on to the next row. First, determine the zero-based row number n and the zero-based position k. There are 13 terms, so we have the 13th visual row of Pascal's triangle. The value of n, which is zero-based, is 12. The 11th position is circled. The value of k, which is zero-based, is 10. The answer is 12. Choose 10. Now we'll move on to part B. Use a combination to find the third term in row 22 of Pascal's triangle. First, determine the zero-based row number n and the zero-based position k. The question specifies row 22 of Pascal's triangle. The value of n, which is zero-based, is 21. We want to find the third term. The value of k, which is zero-based, is 2. The answer is 21. Choose 2 equals 210. Now we'll move on to part C. Which positions in the 12th row of Pascal's triangle have a value of 165? First, determine the zero-based row number n. The question specifies the 12th row of Pascal's triangle. The value of n, which is zero-based, is 11. Now solve the equation 11 choose k equals 165 to find the positions. Using guess and check, 11 choose 3 equals 165, and 11 choose 8 equals 165. K equals 3 and 8, so the 4th and 9th positions have a value of 165. Notice that 11 choose 3 equals 11 choose 11 minus 3, generalized as n choose k equals n choose n minus k. Visually, 3 terms forwards equals 3 terms backwards. Now we'll move on to part D. Find the sum of the numbers in each of the first 4 rows of Pascal's triangle. Use your result to derive a function, s of n, for the sum of all numbers in the nth row of Pascal's triangle. What is the sum of all numbers in the 11th row? Bring up Pascal's triangle. Create a table with columns for the zero-based n value, the sum, and 2 to the power of n. In the first row, n equals 0 and the sum is 1, or equivalently 2 to the power of 0. In the second row, n equals 1 and the sum is 2, or equivalently 2 to the power of 1. In the third row, n equals 2 and the sum is 4, or equivalently 2 to the power of 2. In the fourth row, n equals 3 and the sum is 8, or equivalently 2 to the power of 3. The sum of the terms in a row is s of n equals 2 to the power of n. Now find the sum of all numbers in the 11th row. The sum of the terms in a row is s of n equals 2 to the power of n. The 11th row has a zero-based n value of 10. S of 10 equals 2 to the power of 10, which is 1024.